All right, the last section of chapter 11. We're going to look at the idea of how to solve simple radical equations. Do you notice we have an equal sign this time? First time we've seen an equal sign in this chapter. We're going to see here, we're going to solve equations, so that means we're going back to chapter 3 and making sure we use our properties of equality. Remember, Mrs. Burton's battle cry was isolate the variable by inverse operations, and so that's what we need to do in this section. So just for a real quick little refresher, if I need to isolate x, x is inside the radical. All right, so what am I going to have to do to get x outside of the radical so I can solve for it? That's right, we're going to have to square this. But now remember, because of those properties of equality, whatever I do to one side, I do to the other. And so we're going to see here that this is going to be 5x equals 100. And then we realize, hey, I got to divide both sides by 5 to get x alone. So we would say x equals 20. Okay? All right, now, the one thing that's a little bit different when we're taking care of these radical expressions and when we have to square something, when you square both sides of an equation, the new equation may not be equivalent to the original. So therefore, we have to check every possible root. Now, personally, I think solving these equations is way easier than checking all the equations. So let's go ahead and try this one together and see what happens. If I'm going to solve this equation, I need to solve for x. But for me to solve for x squared, I've got to get it out of the house. So we've got to square both sides. So now when I square what's inside the radical, it comes out. So we've got 11x squared minus 63. But what happens when I square the other side? That's right, we get 4x squared. Okay, now I've got to isolate my variable. All I have is an x. It happens to be x squared. So let's get those x squareds together. So I'm going to subtract 11x squared over here. So now I've got negative 63 equals negative 7x squared. We're going to have to divide both sides by negative 7. So we're going to get 9 equals x squared. Now, how do we go from x squared to x? We've got to take the square root. Remember, x is going to have to equal plus or minus 3. We don't know if it's the positive root or the negative root. So my answer here then, okay, for this equation is 3, negative 3. Now, the problem is we have to check those. We have to check and make sure they're correct. So let's start with positive 3 first. So if I plug that in, we're going to have 11 times 3 squared minus 63 equals 2 times 3. So this is going to give me 99 minus 63, which gives me the square root of 36 equals 6. Now, if you notice, it's the principal root, it's positive, so the principal root of 36 is 6, and 6 does equal 6, so 3 is an answer. Now, let's try negative 3 and see what happens. So, we're going to have 3 times negative 3 squared minus 63 equals 2 times negative 3. Once again, we're going to have 99 minus 63. So we're going to have the square root of 36 equals negative 6. Now, what's the square root of 36? 6, and again, they want the principal root. So 6 does not equal negative 6. So this is not an answer. So you would say x equals 3. Okay, so again, solving the problems is pretty easy. The checks is what takes so much time to get done. So we're going to practice a few together as we go through here. Okay, so let's look at number 1. We need to solve for n, and n's in the house, so we're going to have to square both sides. So now I've got 4n. What happens when I square 1/3? That's right, I get 1/9. Now, for me to get n alone, we're going to have to divide both sides by 4. But since I've got a fraction over here, I multiply by the reciprocal. So we've got n equals 1 over 36. Okay, now we have to check though. We've got to check every answer. So we've got the square root of 4 over 1 times 1 over 36. So that's going to give me the square root of 4 over 36. Now, that fraction reduces. Could do this 2 different ways. That gives me 1/9, and the square root of 1 is 1. The square root of 3 is 3, and 1/3 does equal 1/3. So this checks, and that is your answer. Let's look at number 2. Once again, I've got to square both sides to get x out of the house. So we've got 25 equals, now that's going to be 4 times 3x, because when I square those, that's what happens. So we have 12x, and then we're going to divide both sides by 12. So x equals 25 over 12. All right, now we got to check. So I'm going to have 5 equals 2 root, and we've got 3 over 1 times 25 over 12. Well, hopefully you notice that my fractions are all in the house, so we can cross cancel. So now I've got the square root of 25 over 4, okay, which gives me 2 over 1. The square root of 25 is 5. The square root of 4 is 2. And hopefully you realize that my 2's are going to cross cancel. So we get 5 equals 5. That's your check. So this is an answer. Again, because we're squaring both sides to get x out of the house, we've got to check every answer as we go through. Okay, now, if you notice on number 3, I've got this extra thing outside the house. Okay, remember when we did absolute value and I said when we were solving for absolute value problems, we had to get rid of the fluff? Well, I would call that 6 fluff. If we're solving radical expressions, I need to get the radical alone first before I can get x out of the house. So the first thing I need to do here is I need to subtract 6 from both sides. And so now I've got 5m minus 5 equals 1. And now I can square both sides to get m out of the house. So we have 5m minus 5. 1 squared is 1. We're going to add 5 to both sides. So now I have 5m equals 6. So m equals 6/5. All right, let's check it and see if we're right. So we've got the square root of 5 over 1 times m, which is 6/5 minus 5 plus 6 equals 7. Okay, there's my original. Well, these are going to cancel, so we're going to get 6 minus 5, which is 1. The square root of 1 plus 6 equals 7. 1 plus 6 equals 7, so 7 equals 7. It checks. So this is an answer. All right, number 4 is the one. It's going to take us a little while to get there. All right, so I've got to start by squaring both sides, okay, to get m out of the radical. So this is going to be 5 squared, which is 25, and then we've got the square root of 10 times the square root of 10, which is 10. So this is going to be 250. And then here we've got to do 6 squared, which is 36, and that's going to get m out of the house. All right, we've got to divide both sides by 36, and so we're going to get m equals 250 over 36. Now we may want to go ahead and reduce that fraction. I think 2 goes into both of those, so let's make it 125 over 18. So I've got 5 root 10, I'm checking now, equals 6 times the square root of 125 over the square root of 18. Well, I'm going to make this 25 times 5, and I'm going to make this 9 times 3. So the square root of 25 is 5. 5 times 6 is 30 root 5 over 3 root, that's a 2. 3 root 2. Sorry, 9 times 2 is 18. Okay, so now we can reduce this fraction here, and we're going to get 10 root 5 over root 2. And we're going to have to rationalize the denominator. And so we're going to have 10 root 10 over 2, which will reduce to 5 root 10, which equals 5 root 10. So it checks. So this is our answer up here. So again, I told you solving the equation is the easy part. Checking the equation is a little bit harder. Okay, once again, when you're looking at number 5, we've got some fluff there. We've got some things that aren't in the house, so we're going to have to move that over. So we're going to have the square root of 5x squared plus 16 equals 3x. Now I can square both sides. So we're going to have 5x squared plus 16 equals, and if I square that, what are we going to get? 9x squared. Let's get the x squareds together. So I have 16 equals 4x squared. We're going to divide everything by 4. So x squared equals 4. So x has to equal plus or minus 2. Okay, so for me to get plus or minus 2, now I have to check both of those. And hopefully you're going to see a pattern now. If we check positive 2, I kind of ruined, I can't see my original here. All right, so we're going to try positive 2 first. So we've got the square root of 5 times 2 squared plus 16 equals 3 times, should be minus, because I got to go back to the original, equals 0. And this x is going to be 2. So what do we got? This is going to give me 4. 4 times 5 is 20 plus 16. So we've got the square root of 36 plus 3 times 2 is 6. Actually, minus. So we're going to get 6 minus 6, which does equal 0. Okay, so positive 2 works. But now, what do you think is going to happen with negative 2? We've got 5 times negative 2 squared plus 16 minus 3 times negative 2 equals 0. We've still got 20 plus 16, so we've got the square root of 36 plus 6 equals 0, because a negative times a negative is a positive. 6 plus 6 does not equal 0, so the negative answer doesn't work. So we're going to reject the negative answer and just say x equals 2. Okay, so hopefully you're seeing a pattern. All right, let's go ahead and flip over here to number 7 and number 8. All right, so as I look up here, I know I'm going to have to square both sides. So this is going to give me x squared plus 9. Did you realize that means we're going to have to FOIL those over there? This is going to have to FOIL, or it's a special pattern that we've learned. Now, what's going to happen? Well, remember, as soon as you see that x squared, you got to make it equal 0. But when I subtract x squared to both sides, guess what happens? They cancel. And if I subtract 9 from both sides, they cancel. So we're left with 0 equals negative 6x. If I divide both sides by -6, what does x equals 0. And guess what happens if we check that? 0 plus 9 equals 3 minus 0. Well, the square root of 9 is 3. 3 equals 3, so it works. That is my answer. Okay, let's look at number 8. And again, we've got to square both sides. And so we're going to get 4 equals a squared plus 3a. Oh my goodness, did you realize this time we actually have a quadratic term and a linear term? Oh, back to chapter 5. What do we have to do to solve that equation? That's right, it's got to equal 0. So we're going to have 0 equals a squared plus 3a minus 4. Ooh, how do we solve that? That's right, we've got the x factor. So we're going to have a plus 4, a minus 1 equals 0. Remember, we've got to use our zero product property. If the whole thing equals 0, each part equals 0. So a plus 4 equals 0, a equals -4, a minus 1 equals 0, a equals 1. And now we get to check both of those. So if I go to check them, okay, so let's try the -4 first. We've got 2 equals the square root -4 squared plus 3 times -4. Well, that's going to give me 16 minus 12. So we've got 2 equals the square root of 4. So 2 equals 2, and that works. So we're going to accept -4. Now we've got to try a equals 1. So we've got 2 equals, and we've got 1 squared plus 3 times 1. Well, that's going to give me the square root of 1 plus 3. The square root of 4 equals 2. And once again, 2 equals 2. So on this equation, okay, this equation that we just saw, both answers are going to be accepted. So we would say a equals -4 and a equals 1. Now, we have one more thing we need to look at, this idea of a story problem. And basically, all I want you to do is to be able to take the words and turn it into an equation. So when I look here, we've got twice the square root of a number is 22. All right, we need a let statement. Let n equal a number. We're going to write twice the square root of a number. Of means multiplication, if you remember. I said n and then I put x. Can you believe it? Okay, let's make it an n. Is means equals 22. Once again, we've got some fluff. We're going to have to get rid of that 2 to get n alone. So the square root of n equals 11. What am I going to have to do now? Square both sides. So n equals 121. All right, and that's the end of section 11:9.